Good morning, and welcome to part 2 of removing Uncle Dorkel from his leash. I think that's what I called it. Anyways, I'm not going to show you every single thing I do like I did in part 1. You pretty well, if you've been following along on older videos, you pretty well know how I did this. I'm going to be removing those speakers at each end that I showed you in an earlier video. I'm going to be removing unnecessary wires, and if time permits today, I will be hooking up the wireless receiver, but I have a lot of prep work to do ahead of time. I still have to dig out a relay for the mouth solenoid. So I may or may not get to that today, but we're going to do what we can, and I'll videotape after I do each part. Alright, what I'm going to do is to clean up this mess and remove any unnecessary wires, extra wires or whatever. Now, if you've been following along, everything is built. Basically, this is a big cardboard box. If you look back, way back on the videos, you'll see. And I braced it up with lots of masking tape. It's 2-inch wide masking tape that I got from Home Depot. And then added plywood on the side. This here was for the original head motor, which had a Acme thread bar going across, and it drove a bar and turned the head. Now we're using a car window motor, 12 volt. And of course, for the mouth solenoid right here, you can see it a little better today. We got some daylight coming in here that is a little better for video lighting. And I have to go and dig out a relay to run this, because I'm not going to have that little relay in the wireless receiver sparking away. You got a inductive kickback similar to what you would have in an auto points and ignition system. That's why they use a capacitor across the points. So in addition to helping generate the spark for the secondary. These speakers here, they're just taped in with masking tape, and there's one here and there's another one right here, and I'm going to eliminate them. If you remember, I put a grill underneath each arm. I originally had a little stereo amp in here. What I want to do in the future is to have a motor to raise the arm, to have a pulley on this to pull this arm up. It's very, very hard to do, very hard. But that's in the future. So what I'm going to do now is I'm going to remove unnecessary wiring. As I said, I'm going to mount a little board here, screw it to the, it's pretty thick cardboard and covered with masking tape and other cardboard glued on top of that. So this is not just a thin cardboard wall. This is probably about a good 3/4 inch thick anyways. And we'll mount that little wireless board right here. As you saw on the video that I made yesterday, the range is very good. So when that wireless receiver gets in here, I'm sure there isn't going to be any problem with the range being reduced because it's in here. Alright, so we got a mess here we got to clean up. Here's some extra wires that we're not using. These were extra that were on that plug that I cut off. So I want to dress this up a little bit, refresh my memory on how I did this. This is the mouth solenoid you have to be careful. This head can spin completely around and snap off the eye wire. This here is the eye wire. It goes up inside the neck stick, or the head stick, right here. It goes inside here and into the neck and inside the head and controls the head motor. Now, I have spoken about this before. The way I built this is what we call paper clay. It's available, that's a brand name, I believe. Paper clay is a modeling clay that comes in a package. It's kind of a hard, soft thing, if you know what I mean. You know, you gotta mold it, and then you have wet hands and water, and you work it in. Okay, the back of this head, about in this area here, and down to about here, there's a screw right in this area here. There's a piece of aluminum that's contoured to the back of his head. And originally, when I built him, the back was noticeable. And I didn't really want that. So after I redone his eyes and the mechanism, the motor for the eyes is inside the head. I decided to close all this up. So in order for me to get back in here, if I have to repair anything on the eye mechanism, I have to literally cut, and it's about up into here, across here and down, and then pull this whole back out, and there is a couple of screws that hold the aluminum in. So this is held together with masking tape after I put the aluminum in, then paper clay, modeling clay over this. It took a good week of the warm summer sun to dry this stuff out good so I can add more to it and try to get it as smooth as I could. So it's a major job getting in here. But the point I'm making is I have to be very careful not to rip this out, especially ripping it out here. This is slacked like this so that this head can turn. See, this head turns. This used to be mechanical, hand operated. The stick used to go all the way down to here. And it used to be loose at this end so I could wobble his head as a comedy effect. If you've seen Uncle Dorkel's Christmas special, which was a few years back, you'll see how skinny his neck was. It wasn't as big as this here. And I was able to wobble his head. Now I can't really do that very well. This is a firm rubber hose here, like a washer, water inlet type of hose, clamped down to the gear output of the car window motor. So that I have to be very careful because there is no stop on this. If this wireless, for some reason, receiver goes crazy due to an external triggering from another source, let's say I have him out somewhere, and for whatever reasons, very unlikely would happen, that something triggers the wireless remote and turns his head could keep spinning around and snap these wires right off. There is no stop. This motor will just keep going around. It's only stopped by me controlling the buttons. So that's just the way it is. I have no stops on here. Original design was by John from the UK, the Solder Shack, on the original one with the Acme thread gear driven assembly, with the motor being over here, he had micro switches on each end, and when it reached the end it would stop. I can do that. I still got those micro switches, but I don't really need to do that. It's going to complicate the thing, and it's going to make it very difficult for me to work up in here if I want to add a head motor. Now I'm not going to be, not a head motor, an arm motor. Now if you look up here, this is a pulse width modulated motor control unit that I got off of eBay. I don't even know where I bought it. It was recommended by one of my viewers when I was trying to control the speed of the head. And the speed control potentiometer is right here, mounted on a little bracket. Okay, so I can remove this speaker, that's not a problem. But as you can see on this side, I'm not going to be able to put an arm motor in here like I thought I was going to be able to do in the future, because this is in the way, and I could move it, but I don't think there's going to be enough room anyways. However, the right arm, his right arm, there is enough room in there, and you can see that little cord with the string. You can probably see that right here. Well, that'll have to come out of there, and the arm lightened up, and then I can probably put a motor in there once I remove this speaker here. Most of the wires are just taped down with masking tape on top of masking tape, and a lot of these wires, as you can see, are buried way inside here. See? And in order to remove these speakers, I gotta remove all that wire, because this wire is soldered on to the speakers and then wire tied in here. Here we are, when John from the UK sent them to me. So they're good high quality speakers. I believe they're 3-inch. Now on the iMotor, as I said, I believe it's a 6-volt motor, but you know what? It may not be. I'm not going to open that head up to look in there, but I think it was a, it might even have been a 12-volt motor, but I'm running it on 6 volts. So I could probably come off of this 12-volt battery. Instead of putting the 6-volt in here to run the eyes, I could probably come off of this battery and put a resistor in series with this iMotor, because the iMotor only draws, I believe, at the most about a half an ampere or 500 mils, if even that much. It may not even be that much. All right, I got to get going on this. I'm chattering away here. Pretty soon it'll be dark. It's only about 9 a.m. right now. I'll be back on this as soon as I get along a little bit on removing stuff. I got to cut some masking tape out of here, pull some unnecessary wires that are no longer being used. I have to check what I got in here that I need or don't need. All right, I got these speakers out. These are nice little speakers that John from the UK sent me. And there's no point in leaving them in there. I can probably use them in another project. These wires he put on there, and they slipped into their little terminal block on the back of the amplifier, which I don't have anymore. I had to loosen the board. It was only held in with one screw over here, so that I can remove the wires, which were all taped up to the back. So you see how this wire is here? This is the power wire for the amplifier, which I don't have anymore. I'll probably leave that in there. Everything was like masked and taped to the back here. I had to pull a lot of this stuff out, so I'll just redo this. So now I can't add, as I said, I cannot add a arm motor in the future for the left arm. All right, this window motor is 7.5 inches from here to the tip of the motor. Okay, with the gear coming out this way. So in the future, if I want to add a motor here, I have about 7.5 inches from the very top here to the top of the fuse board here, and about 5.5 inches, maybe 5, horizontally across here. So that's in the future. I'm not going to worry about that now, but I'm just taking measurements for future improvements. Alright, I couldn't find my 2-inch wide masking tape. I got so much damn junk in that shed, it's unbelievable. I know I got it, so I had to use my my blue masking tape I use for body work. What I did is I put some cardboard and some foam rubber, some of this hard, you know, kind of like hard foam rubber in there, and taped it over. And the reason is we had an open grill here, and we don't want any more sound coming out of this cavity because of these relays can be heard across the room when they click. So it's important. We're going to do that over here too. We're going to close this off. You notice this is 1/4 inch plywood right here on the inside of the cardboard. So we're going to simply close this hole off because we're going to need, this is all cardboard here, plywood here, 1/4 inch Luan actually, or press board, composite board I believe, so that if I do put a motor in here in the future I'll have something to screw to. So we're going to put something in here to close this off too in the future. We're not going to do it right now. Up here is a thin wire to run this little speaker up here that you may or may not be able to see. The head stick is in the way. It's right there. This wire here is for the subwoofer here. This connector could come off because this went on that little amplifier that was in here. So these will be the only wires that'll be left in here, along with the little power wire that was originally supplying the amplifier. We're going to leave that in here because that's 12 volts center pin positive, so if I need to put anything in here I'll have it already here. So we'll tuck that down in here, and we're getting some sun, and that's good. Alright, I'm in the process of tracing out. I stripped these wires back, and some of these wires trace back to the head motor, but we're going to mark them and put little tags on them with this blue tape so that when I wire it I'll know what's what, and whatever spares they're in here. I think the spares, there's one is a negative. At least one of these is a negative. Sometimes I might have even used 2 for negative, anticipating a higher current draw, so I probably doubled up on them. But whatever. All your main circuit now for operating goes through this anyways, and although these wires are not as heavy as these, it's all I got for red and black right now in that gauge, and it's not bad. It's all wired in here anyways, and it was a little awkward for me to get in here to solder at the time, so I think I'll probably just leave these. These are just heat shrunk on here. What I'm going to do, as I said before, I'm going to put a main on-off switch. I need to be able to shut this thing off in a real quick hurry in the event that something goes wrong with the you know, the wireless receiver, it shorts out or something, and the head just keeps turning, and you know what'll happen here, as I said. So I'm going to be tracing this out now, and I'll get back to you in a little bit here. All right, all three of these black wires, so they all go to the common negative. As I said, all the black is negative. So it all returns back to this. All right, so they're all connected. Now, these are going to be positive or switching. This white wire here goes to one of these 4 wires here. One of these 4 wires has got to supply 12 volts to operate this mouth trigger. Okay? So let's trace it out. And then we'll hook a battery on it to prove my point. The minus of the battery will go on to any one of these 3 black wires. And I'll probably just parallel them all together, but it doesn't matter. Don't really need all that. We're not drawing that much current. We're only drawing about 6 amps. About 6 amps on the mouth trigger and about 8 amps on the head motor. That's the average draw, or a little less. We're not talking about the stall current. The stall current, I believe, is over 10. Okay, let's trace this out right now. Let's get on here and trace it out. 0.5 ohms, half ohm. All right, here we are on the mouth trigger positive, right here. All right, so we're going to label that wire the mouth trigger. I'm going to get a battery out here now, and it will work. As I had mentioned in my last video, the mouth solenoid can go hundreds of times a minute sometimes in the skit. And these door lock solenoids are not made to go that way. So that's why I got to limit, when I'm doing the skit, how many times his mouth has to move. It's a solenoid right there. Let me get you inside here. All right. According to my amp meter, and I tried both digital meters here, I'm reading. I got it disconnected now. I'm gonna key it up. Under 3 amps. That's the mouth solenoid, under 3 amps. I don't notice a lot of sparking. There's a possibility that maybe I won't need that intermediate relay. The relays, I believe, are 10 amp in that wireless remote receiver. This is well under that. I had thought this thing drew about 6 amps on the solenoid, that is. But no, it's drawing under 3, about 2.7 thereabouts. So that's the mouth solenoid positive. So we could probably bring that right directly into the control unit. I just don't want to damage the relay in it, because if I do, I'll have to change the entire thing. I'd have to get another one. And probably get one with maybe 2 more channels. So in other words, 6 channels to operate a motor for the arm, but I don't know if we're going to even be able to do that. So right now this will work out just fine. So that's what we've got here. So 12 volts is fed into this wire, which will go to the mount trigger and energize it. So this will go to the relay on the receiver for the mouth button to connect to the relay for the mount trigger. These are minus, as I said, and now we're going to trace out these others here. We'll do that off camera. Alright, I have these marked. This is the mouth solenoid activation for 12 volts going in to activate it. These two are plus 12 volts, which are supplied through the red wire of the battery here. So these can be used for feeding in whatever needs 12 volts. But we still got a mystery wire here that doesn't seem to connect to anything. Pretty good. I built something. I don't even know what I'm doing here. Eyes aren't working too good, but that is the eyes. Yeah, they're hardly moving. Alright, so that's 6 volts. So we know that that's the eye wire, so we're going to label that. Now, I can put a drop-in resistor on that, which I'll probably do to run that, but you know, it looks to me like I might have to go into this head, and I really don't want to do that. I really don't, because obviously the mechanism is slipping badly in there. There was no real way to hold the to couple the loop, the way I got it so that it loops around, and you know, there's like a hook in there and it just goes back and forth. I had to crimp it with vice grips onto the motor shaft, and I knew it was going to loosen up. There's not much I can do. Looks like he's getting a little crack in here in his ears. Good and solid though. Anybody in there? Empty head. If I recall, I think that motor might have been a 12 volt, but I'm running it on 6. But if I put 12 volts in that, I could ruin the mechanism altogether in there, trying to drive it too fast. And the eyes may stay off completely, then I'm going to have to open the head, like it or not, to get the eyes centered. They're not quite centered right now, and they're getting worse. He may need a head operation, and that's going to be a big problem. I really don't want to tear that head apart. Alright, so let me label this and I'll get back on this video. Alright, it don't look like I accomplished much, but it's about an hour later, maybe an hour and a half later. I'm just deciding how I want to route these wires. I pulled them out of here. They were hanging up over here. I pulled them out, and we're going to take all the wires and we're going to put them and cable tie them to this strap back here. And I'm going to extend these positive wires, these 12 volt positive wires, and the mouth solenoid wire. We're going to extend them using some 18 gauge primary wire that I found in my shop. So that'll work out perfectly. Because these are white, they're all going to be taped and wire tied here, and they'll end up about here. So then I'll just add the red wire to them, bring the wire over and down, and I'll have a little piece of 1/4 inch Luan. I'll screw into this here, and that circuit board, that receiver board, will be mounted on that. So what I want to do is make very sure I'm not going to screw into any wires, because everything's under tape, and I think I eliminated everything and dressed it up here so it's not in the way. I taped back this white wire so it wouldn't hit the mouth solenoid as it spins around, because this don't spin even. So that way we can make all our connections, and whatever connections we need to bring into here. These are extras. So that's what we're going to do. The first thing I'm going to do is extend these wires. Then I'm going to find a little piece of Luan, which I think I have in the shed. Doesn't have to be very big, just a little bigger than the receiver, in case I want to add anything else to it. And because the mouth only draws about 3 amps, we're going to use the relay that's in the receiver. On the mouth solenoid wire here, later on we're going to add a diode across here so it doesn't develop any sparks. So we'll put a diode across the motor itself. Alright, I extended the wires. I did not mark the other red ones. You remember these were white coming out here, and there were 4 of them for B+, and 1 for the mouth. So I only labeled the mouth here. I may have to shorten these. And I taped them completely like you see here. I got heat shrink in here, so that's why it's a little bulky. So now we just have to worry about just red wires. So all red wires, with the exception of this one marked mouth, is going to be 12 volts plus. So we have no problem with that. And this will come around in here. It'll go over here like that. I'll put a clamp in here. I want to leave this board free here, so we'll put it here. We'll run it over and to the circuit board for the wireless here. And what I'm going to do after I put the plywood in here and get the board ready to mount, I'll trim these up to the length that I need, and I'll do my wiring out here where I can see it. You've seen the difficulty I had trying to get the wire in them little holes, which I think are a little bit small for 18 gauge wire. Either that or I just can't see. Probably the latter. I'll do it out here, then bring the whole thing in here. So we're gonna do that. And the eye motor, even though the eyes are not working good, so what I can do is experiment with a resistor. Everything's experimental, as I told you so many times in electronics. So we'll take a, I don't know, maybe 1,000 ohm resistor, put it in series with the motor, and try it on 12 volts. We're going to do that before we do this here. And we'll put a voltmeter on the eye motor. I didn't relabel the eye wire. That's not a problem. I can find it. It's one of these here. I labeled the mouth again, but I tore off all the labels that were on the end of the white wires over here when I heat shrunk them up and everything else and connected the red wires to it. But I didn't transfer a tag out to the end here. But like I say, we'll do that. We're not lost, believe me. All I got to do is ohm out everything to this red wire here. Everything that reads 0.5 ohms or less, because there is a drop of resistance in here with the leads on the meter and this wire, is going to be B+, and 11.5 ohms is going to be the resistance of the motor. So, all right, let's stop talking here and let me get going here. I have a 100 ohm, I guess this is a 5 watt, could be a 3 watt, but it looks more like a 5 watt. Anyways, 100 ohms, here's the I wire. We want to keep 6 volts on this, and we don't need to order a board off of eBay, you know, to bring it down to 5 volts. I have a feeling these eyes are going to be, you know, totally failing very, very soon here, and I may, like it or not, I may have to tear the head apart anyways. So what I can do is just put this in line. Now I don't need this kind of wattage, but I don't have my tripod out here today. I can get it. All right, I got the negative common, which is common to all in the Dorkel body. Voltmeter is connected to the negative, and the positive, we're going to turn this on, it works better that way. All right, on the 12 volts, we're getting 12.8 volts unloaded. Now, what I'm going to do is hold this lead on here. So I'm holding it on to the I wire and want to see what the voltage is that I get. I'm only getting 1.14 volts. Okay, so that's 100 ohms. All right, like I say, we do everything by experiment. We have a 10 ohm, looks like half watt. It could be 1 watt. You know, these modern resistors are smaller for the same size. Let's go on here. Find a hole here. That resistor's warm. That was 11 volts. Wow. We can't have that. Here is a 47 ohm, and yes, that was a 1 watt resistor. But that was running a little bit warm for that short time here. So let's all right, we're clipped on the eye here. We've got our wire here. It's all over the place because it's drawing current, and that is warm. That's very warm. So voltage regulation isn't too good going to a resistor. It's down to 4 point something, and it's over a little over 6. It's varying all over because as the motor is loaded down when it's shifting those eyes, it's fluctuating. She's running at about 9 volts right now. Resistor just barely warm. 22 ohms. That's I happen to find. So I know that's, you know, lower. She's running. It's varying because of the load, you know. I think we can live with that. You can hear it. I better shut this off. Alright, I found a 32 ohm resistor. These are power resistors I got from Antique Radio Forum Classifieds last year. The guy was selling a whole bunch of power resistors because I just didn't have any in stock. So a lot of them I will never use probably, but I found one over here. A 32 ohm 10 watt. So okay, so we were running 22 ohms here, and we're running a little high. We should be about right running this. Like I say, I experiment. You can see every time it moves. That's a little better. You can hear it? put the microphone of the camera right up against the head. Okay, so that's what we're going to use. I've got a board that'll go right in here. Of course the wires are in the way because I'm doing this one-handed. The mounting screw to hold the board to the wall here will be right here. We're going to put the circuit board up here. The problem is it doesn't have a conventional mounting. It has one of these mountings here. Mountings, I should say. Unless I glue this down on the board, because I don't want to have to put a screw in here and then try to get it to fit in, because it's gonna flop all over. I think we'll hot glue this in the workshop. Okay, I hot glued this on the back and then all around the edges. Now obviously I'm not going to be able to snap the cover on that, but that's okay, because it's not going to hurt anything. It'll all be exposed just like everything else is in there, and when it fits up in here, it'll be screwed in with one screw where my thumb is right there, but it's going to be pre-wired first, and these thin wires will be removed and my regular 18 gauge will be used. Alright, these wires are going to be very, very long, but I got to work outside here. I had all I can do to get these red and black wires in there, so I can threading a needle. All your A's are going to be 12 volts. All your A's. C is not used. As I said, all the screws are down all the way. We're not using C. We're using A and B. A is going to have 12 volts on it, and B will be whatever circuit the 12 volt is going to be switching. I probably did a little overkill with this hot glue, but I had to put it on and then bring this board over, and I didn't want it to set up too quickly, and I didn't want it to fall off, so I just went around afterwards with it. Okay, so now the mouth, since we're only drawing 3 amps, its wire will go into one of these two here, because as I recall, the A and B buttons are to the right. In other words, it's not A, B, C, and D. It's A, B, C, and D this way. It's backwards. So it's easy enough to change because it's only held in with one screw. That's going to go in this hole here that I made in this board. And I don't think I have to fuse this board. These here are rated for 20 amps according to what I see on here with the magnifying glass. So does that mean that this thing gets fused with 20 amps? This is, if anything shorts out in this board, as sure as heck ain't going to take out the 20 amp fuse. So the entire Uncle Dorkel electronics is fused with a 10 amp fuse. So we're good for that. We'll leave it that way. What a hell of a job I'm having with this. Obviously these things will not take two 18 gauge wires in here. I just cannot get them in there. What I'm going to have to do is to have I'm going to have 4 12 volt lines going in here, 5th counting this one. The only way you can do it, you can only get one of these wires in these slots here. 1 18 gauge wire. This is 18. So we're going to run 4 separate 12 volt lines in each A. We're going to run them in there. We're going to make 4 pigtails, and we're going to come out and feed them into one of these 12 volt lines. That's the only way I can do it. Okay, this is the way I'm doing it. Then I'll be able to, when I mount this board in there, we'll tie all these together to one 12 volt line. We'll strip them, splice them, heat shrink them to one of these 12 volt lines. I've got 2 extra 12 volt lines, not counting what I can tap in up here if I have to, but then I'd have to put a terminal strip in there. So, and we're not going to try to tap off into here. You cannot put two 18-gauge wires in these slots. They will not fit. So now the next thing I got to do is I got to bring in on terminal B the head, which is these two relays, one for the left, one for the right. This one will be for the eyes, and this is going to be for the mouth. So that's the way we're going to do that. Okay, so now we've got all 4 positives connected so that each circuit will get its 12 volts, including the eye motor, and that'll be dropped to that 23 ohm, 32.5 ohm resistor to be exact. And the eyes are gotta go into here, but they're going to have to go through the resistor first, because everything here is supplied with 12 volts. Hello, my name is Uncle Dorkel. I'm pushing this. It's not going to do it. You see that like this? So I can't have that. There's a delay there. And if I go fast, it should open and close just like it did before. Nope. All it's doing is staying open. So, we've got a problem in Houston. I'm going to end this video now. I'm going to put that board in off camera. Put things away here. See, the head is not a problem, because it doesn't have to, it's not like instantaneous, boom, 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 you know, like you do with the mouth. The mouth has to respond immediately. I don't know how to do that without having a wired system. I don't think it can be done. I don't think there's any such thing as a wireless remote system that could make the mouth move. As I said before, this mouth has to move hundreds of times during the skit. It just can't stay open like that when he's actually talking. It's just not acceptable. Alright, I'm ending this video now. I have no idea if this is going to all go into part 2 or not. I probably edit it down to try to do that. Okay. Thanks for watching. Don't know when I'm going to get back on this again, but I'm going to close it up and put this inside here. And temporarily not put the resistor in, because the eyes aren't working that good anyways. For now, I'll just screw it in, and it'll come out. It'll come out very easily. It'll sit right in there, and it'll be screwed up in there. I just got to get a little screw to put in there. Thanks for watching. We got a lot of figuring out to do with that mouth solenoid.